Now, the Prime Minister has had something else on his mind this week. It's his twice cancelled trip to India. Covid levels there are getting pretty serious. It registered the biggest spike in the world recently. And he figured, perhaps understandably, now is not the best time for a trip. But how much of this is down to the new variant strain of Covid that's been discovered over there? I'm joined by somebody who can distill the facts from the panic. Dr Jeffrey Barrett directs the Covid-19 Genomics Initiative at the Wellcome Sanger Institute in Cambridge, and he joins me now. Dr Barrett, welcome to Spectator TV. Now, we've heard a lot about the Indian variants, but what do we know about it, and to what extent is it overwhelming India in the same way that the Kent variants changed the narrative here in Britain and on the continent?
Yeah, the short answer is I don't think we know yet. There is some evidence that this new variant, dubbed B1617, has been growing in frequency in India at the same time as the recent tragic surge. But that can sometimes happen by coincidence, and it doesn't necessarily prove on its own that the new variant is in fact driving that surge. The way we tried to unpick that problem in the case of the Kent variant back in December last year was we could watch, because we do quite a lot of what we call genomic surveillance in the UK, where we sequence the genome of the virus to really carefully track each variant from place to place. And what we saw there was that every time the B117 or Kent variant would arrive in a new place in the UK, it would very rapidly completely take over. And we've seen the same thing happen in other countries in the months since then. So that takes quite a lot of data to build a sort of very compelling picture. And I think right now, we actually just don't have enough information about this new B1617 variant.
Right. And how difficult is it to track? Because the Kent variant, that was detectable by an S gene dropout, which you can pick up through a standard PCR test. Is the Indian variant one that you would need more advanced methods to detect? And is that why there's such a question mark about its prevalence?
That's exactly right. So the Kent variant had a kind of coincidental useful property in that one of its mutations made it, as you said, trackable by a certain signal in the PCR test that we use very widely. And that means we could see it in kind of real time and also in very large numbers of tests conducted in the UK. The B1617 variant in India doesn't have that property. One needs to read the complete genome of the virus in every sample to be certain whether it's present or not. And at the moment, there's a growing but relatively small amount of genome sequencing in India. So they've had over 4 million cases in this current wave, but only published about 1,000 sequences. So it's a tiny proportion, and it can be very difficult to know if that proportion that have been sequenced are representative of the huge number of cases that are being transmitted. And if they aren't, then that means you can't sort of make the leap that the exact proportion we see in the sequence data represents how much is out there in the country as a whole.
Right. Now, there's been a lot said about how this is a double mutant strain, which sounds pretty terrifying. Is it?
Yeah, I think that's really overblown. So all of these variants of concern that we've been looking at, the Kent one, the B1351 from South Africa, the one that was first seen in Brazil, these all have a number of mutations. So the virus has about 30,000 letters in its genome, and usually these variants that seem concerning have 10 or 20 mutations or differences from the ancestral version. The same is true of the Indian variant. It has, I forget, about a dozen, I think, 2 of which are potentially concerning, and those 2 are why someone coined it the double mutant. One of them was previously seen in a variant in California. I'd actually say those 2 mutations that have grabbed headlines are not in the top tier of biologically scariest mutations, compared, for example, to some of the ones in the Kent or South African variants. And for that reason, I think we don't know whether it's very difficult to predict this virus and whether there might be some aspect of its biology we don't understand. But I don't think there's any need to panic right now. I don't think there's any clear evidence, for example, that these mutations would make vaccines less effective against this variant.
How many mutations are there of COVID that we know, or how many can we estimate that there are so far?
So there are many tens of thousands of mutations, because these things happen sort of all the time in the virus, in all the transmissions that are happening around the world.
So tens of thousands of mutations. But why should it be that when we see one from Kent, one from South Africa, one from Mexico, that we talk as if the very mutation is reason to worry and there's something going on, if there are tens of thousands of mutations anyway?
Well, I think that's a good point, and almost all of the mutations we see do basically nothing to the virus's biological properties and are not interesting, except they can be used as a kind of barcode to track the virus. The reason that we do get somewhat excited about the Indian variant and the Kent one and so forth is that some of those mutations have properties that make them perhaps more worrying. So, for example, when they appear in the spike protein of the virus, that's the kind of most important bit the virus uses to bind to human cells, that is likely more concerning. More recently, there have been a number of laboratory experiments where specific mutations have been tested in viruses in dishes to show that, for example, they can bind more tightly to human cells and infect better, or that possibly they can evade certain antibodies that our immune systems produce. So I think we're getting better at having these predictors of which mutations are a bit worrying and which ones are probably benign.
And meanwhile, we can keep account of them, can't we? I mean, the variant's been here for several months now, since February, and right now I think there's only something like 100 cases being detected. So can we infer from that the Indian variant, whether it's more dangerous or not, is certainly not growing in the way that the Kent variant has pretty much taken over the COVID story in continental Europe?
I think that's likely the case. It's difficult to make a direct comparison because, of course, in the last few months, the country's been under a tight lockdown, and that seems to be driving down the numbers of all variants of the virus, which is very good news. But one thing that's becoming clear is that of the 100 or so observations so far, almost all of them, I think, are either from people who recently traveled from India or the contacts of those travelers. And that means that, in some sense, the early warning system is working. We're detecting that now. We know there's a lot of cases in India. We know a lot of people test positive when they travel from there. And a reasonable fraction of them have this B1617. But it doesn't seem yet to be transmitting onward in the community generally. And I think that's a very good sign so far, and obviously something we have to watch very carefully going forward.
Right. Now, I imagine, well, can you ever see a time where we would not be worried about a COVID mutation? It's argued that as the virus enters its final years, we can in anything expect more dangerous mutations as it seeks to evolve and dodge the vaccines. But I'm thinking that right now, if we're closing our borders, if we are taking very strong quarantine regulations because we're worried about a potential mutation for the virus of where there are tens of thousands of mutations, I can't quite see the process where this ends and where we would not be worried. From what you're saying, COVID will keep mutating for the rest of its life on this planet, and I can't quite see at what point we stop worrying about mutations.
Well, I think in some sense that's right. We're entering a kind of new phase of the pandemic where there are variants around the world, and we watch carefully and are most interested in knowing if any of those variants are less well neutralized by vaccines. And I think we don't know yet, and that's the reason for concern. That being said, I think it really emphasizes a fundamental point that a number of people from the WHO and others have made, which is nowhere in the world is really safe until everywhere is safe. It is not sensible to think that if the UK successfully finishes vaccinating its entire population, but there are hundreds of thousands of cases per day in India, that the pandemic is somehow over for us. Travel restrictions are one way to try to limit that sort of import and onward transmission in that situation. Obviously, Australia and New Zealand, for example, have been doing that for months already. But I don't think anybody wants to live in a world where we permanently have such strict travel restrictions. And I think that's why efforts to more equitably distribute vaccines around the whole world are so very important.
Sure, but this is what a lot of people can't quite understand. If we end up with herd immunity in this country, the government thinks we're going to get there by October, some think we'll get there earlier, but say if we hit there at one point, isn't the whole purpose there that any variant of COVID, any one of the tens of thousands that you've spoken about, ought not to trouble us, simply because it wouldn't be able to spread, because it wouldn't find enough people to spread to? I can't quite work out why, if we do hit herd immunity, which is the government's strategy, perhaps an undeclared strategy, but if we hit herd immunity through vaccination, why would we then be worried about people bringing COVID into Britain if we're not aware of any mutant strain which dodges the vaccine or causes reinfection?
Well, exactly. That is the X factor, which is there are no variants yet proven to dodge vaccines or cause reinfection, but there are some for which there is reasonable concern or worry that they might be better able to reinfect individuals who've been vaccinated. And that's I think, hopefully not a very likely outcome, that there will be fundamentally variants that will be able to evade the vaccines at a very substantial level. But obviously the consequence of that is so enormous that I think governments are taking precautionary steps to say, we get to herd immunity, we try to gather as much data as possible to understand if these new variants pose a real threat to that herd immunity, or if there is, for example, a possibility that some of these variants might create some infections, but they'll be relatively mild, possibly unlikely to transmit onwardly, and very unlikely to become severe disease or death. And that might be something that society can learn to live with. So I think that's the question, is which of those possible scenarios is likely to play out? An unlikely but very bad one, where we'd have another wave of a new variant of the virus, perhaps also unlikely but very rosy one, where the vaccines work perfectly against every variant of the virus, or something in between, where we have to sort of adjust our lifestyle in response to exactly whether there are other variants and how much they might not be as neutralized by the vaccines.
But at what point can we declare that we're no longer worried, for example, about the South African variant that was found in some laboratory tests and in some real-world tests to be better at getting through the Astra vaccine, for example? And then there's some studies in Israel recently looking at people who had been infected despite having been vaccinated, and they found far greater prevalence of South African variant than they had thought. But still, if you look at South Africa itself, their cases are down something like 98% from the peak. So I'm not quite sure at what stage we think, okay, we've seen a couple of concerning studies, but realistically it's not that much of a threat. It's difficult to declare with any confidence that whatever new variant it is, be it Indian, South African, Brazilian, is no longer a threat. You're going to get concerning studies that are always going to, aren't they not, give us pause for concern. I just can't quite see when this cycle would end.
Well, I think we will get more informative data. One of the studies that you alluded to in Israel is informative, I think, in that they did see a larger proportion of infections after double dose vaccination of the South African variant, but the total number, if I remember rightly, was something like 8.
Yeah.
So it's
tiny.
Perhaps this is where I was going, that it can perhaps get through a bit better, but it's not as if Israel is experiencing a wave right now of South Africa variant getting through their vaccine. So I think that's a good point of confidence. I think you'll see again perhaps some data from the eastern part of France and Luxembourg and Europe have a reasonable amount of B1351, the South African variant. They're also vaccinating quite quickly, so we should get data there. And we'll also be looking very carefully in the UK. Here, we have very low levels of the South African variant in the community, and the government is trying hard to get that to zero with things like the surge testing in South London we saw a week or so ago. But I think what we'll do in the next month or so, as restrictions are lifted, we sequence a very large fraction, more than half now, of all the new positive cases in the country, so we know how many cases of these variants there are, and we'll be able to ask questions like, are we seeing more cases of South Africa now that we're getting close to herd immunity? Are they enriched in the vaccinees compared to other lineages of the virus? And I think you're right that hopefully there will be a kind of drumbeat of reassuring stories that will mean we don't have to be quite as petrified of these variants as we perhaps have been.
Of course, we're talking about vaccines all the time, but a variant which causes reinfection is as much of a risk. Now, it's more than a year since the virus kicked off. How many countries have there been where reinfections have been a feature of the pandemic? I was trying to have a look at reinfection numbers, and they're pretty hard to find. I think there's a Dutch company which tries to list them, and it's got fewer than 150 documented reinfections worldwide. That struck me as a very low number for a virus where there have been tens of millions of infections. I don't know if your institute has been looking at this in any greater detail.
So we haven't in particular, but we have been contributing data to it, to I think an important effort to look at this. It turns out to be just very hard to prove reinfection. Sometimes people, for example, shed virus for months after they've been infected at a very low level, and it can look like another infection, but really it's just some kind of unusual tail of their first one. So there have been studies set up to try to find these things. There's one called Siren in the UK, which is a study of healthcare workers, where you can imagine is a good place to look because, one, it's much easier to keep careful records and do things like sequence the genome of every infection to know conclusively this is a different variant than the person got, back in October of last year or whatever. And the other thing is, of course, healthcare workers are exposed more often to the virus than most of us are. So there are efforts to document these numbers. It's still, as you say, these clear-cut cases are small numbers. I suspect there are more in the community. There's an interesting piece of data.
Can you say a bit about what the Siren study has found? If you say that is Britain's #1 reinfection study right now is Siren, what has Siren found about reinfection levels? How many reinfections has it found?
Well, I think what it's found is that previous infection offers, as we would expect, very substantial, I think it's something like 85% reduced risk of getting infected again. And I don't think they found, as yet, any association between secondary infection and which variant is you're exposed to the second time. I suspect that's going to take a bit more time because the sort of types of variants that one has been exposed to in the UK has been shifting over the period in which the study's been running. So, back last fall, it was one particular mix that swept through being Kent to the point where today 99.9% of new infections are the Kent variant, so it's kind of quite difficult to tell them apart. I think there's also some interesting data from the ONS, Office for National Statistics, and Oxford University study, which looks at the general population survey every week. And one thing they've found is pretty consistently, there's a way the PCR test measures approximately how much virus is in the sample that you take, and that second infections tend to have less virus than first infections. And I think that kind of makes sense, so that even individuals who do get a second infection probably get a more mild infection. And they also might be less aware that they even are infected the second time around if they don't have strong symptoms. And that might also be a factor for why so far it's been very hard to pin down numbers of reinfections in the community, because the second time round it might be less likely that you notice.
Right. And it's funny, when you pick up the papers abroad, people talk about the British variant as if it's, which obviously is a major problem for them. But I'm wondering, what do you think the chances are that the British variant actually started in Britain? We do more genome sequencing than any other country in the world, I think, it's fair to say. Isn't it simply more likely that we found it first, but it probably started somewhere else?
Well, I think that was certainly a possibility when we first observed it, for exactly the reason you say. We had a very powerful microscope to look at these things, and so when we found it, it was hard to tell the difference between whether it had originated in Britain or somewhere else. I'm not sure, but increasingly confident it probably did originate in the UK. And the reason for that is it seems to transmit so quickly that if it had arisen somewhere else some substantial amount of time before it in the UK, there would have been a very bad wave there. And in the wake of the discovery of the British and South African and other variants, many, many countries are now doing sequencing, and we haven't yet seen a country turn up where we can look back and say, aha, they probably had a very bad wave that was caused by this. Instead, we usually see it kind of starting in other countries on a lag of months from when it began in the southeast of England. So again, no way to be totally certain, but I think it is reasonably likely that it began in either the southeast, somewhere in Kent, or possibly in the east of London, which is where we saw the very earliest sequences in the UK.
Okay, but so far, I imagine no virus has ever been scrutinised with as much expertise as the coronavirus has. We're not seeing any significant number of reinfections. They seem to be absolutely tiny, and we're not seeing any of the tens of thousands of variants that dodge the vaccine. Might it be fair to say that that's two pieces of reasonably good news?
I think it probably is. I mean, I think we can't be too certain yet that none of these variants are going to be less well neutralized by the vaccines. I don't think we have seen, I think one way to put it would be, we have certainly not yet seen a really bad piece of news about a particular variant and vaccine efficacy in real world data. And as you kind of said before, the longer that time goes by and there are variants out there in countries where there's a lot of vaccines, the more and more that kind of lack of bad news becomes good news.
Dr. Jeffrey Barrett, thanks very much for joining us on Spectator TV.